Everyone, I am Ariel Selva. In today's video, I am going to tackle about how OSI layer model works and to differentiate the two cables in which it is the see-through and the crossover cable. So first is we are going to understand the OSI model. So Open System Interconnection, or also known as OSI model, is presented in 1984 by the International Organization of Standardization, or ISO. Based on examination of existing protocols, ISO recommended a 7-layer network model. It allows vendors to implement networks that permit communications among the wide variety of network implementations. The OSI model is not an absolute standard for computer networks. It is used as a reference model, and these are the advantages of OSI. So first is it simplifies the networking model. Second, enables programmers to specialize in a particular level or layer. Third is provides design modularity. Fourth is encourages interoperability and allows networking vendors to produce standardized interfaces. Reasons for layering. So first is the protocol. It is a defined method for communicating between systems. Computers most use a common protocol to communicate properly. Examples are TCP or IP and IPX or SPX. So next is the per OSI communication. Per communication, each layer will only talk to its pair on the opposite side of the communications process. Each layer is unaware of the activities of other layers of the model. Allows error checking to occur on two separate layers simultaneously, and each layer does provide services to the layer above it and receives services from the layer below it. Layers do not acknowledge these services in any way. The OSI model was developed as an industry standard for companies to use when developing network hardware and software to ensure complete compatibility. Each layer in the OSI model performs a specific function of the transmission process. Most modern networks do not implement the OSI model exactly as it is defined. So there are 7 layers of OSI. First is the physical. Layer 1 and responsibilities defines the physical characteristics of the network hardware, including cable and connectors. It represents binary digits as voltages or encoding, and it also transmits signals on the wire. Next is the data link, or the layer 2 responsibilities. NIC software functions, including the identification of the source and destination nodes via their physical addresses or media access control addresses. It is defined on how data is packaged for transport in smaller units known as frames. It has also an error notification. The data link sublayers are logical link control, or LLC layer, and the media access control, or MAC layer. So next is the third layer functions, or also known as network functions. It is a software or logical addressing for data packets such as IP, IPX, and AppleTalk, data routing, and connectivity. It has best path selection, and its protocols at the network layer allow computers to route packets to remote networks using a logical addresses. The fourth layer is the transport responsibilities. End-to-end error, pre-transmission and delivery between the ultimate sender and ultimate receiver. It has a flow control and a data segmentation into maximum transmission unit or MTU size. It messaging service for the session layer. Protocols that reside at the transport layer can be connection-oriented or connectionless. Data sent by the connectionless transport is called a datagram. The fifth one is the session services. It controls for data exchange or full or half duplex. It clocking or timing. It failure recovery. And it has initial link setup and link termination when communication is complete. The session layer allows the transfer of a large set of data across the network. Examples of session layer protocols include NetBIOS, SQL, RPC, and X Windows. The sixth layer is the presentation responsibilities. Data translation, data formatting, data syntax restructuring, data encryption, and data compression. This layer also provides encryption services when data encryption is used in network communication. And now, the last is the application responsibilities. Initiating the request for network services. It is providing network services to applications such as email and web browsers. This layer is concerned with user interaction with the computer at the network. It contains many protocols and utilities such as Telnet, PTP, HTTP, DNS, SMTP, and SNMP. In data encapsulation, data is sent from one computer to another in a data packet. Each layer in the protocol stack may add a protocol data unit or PDU to the data as it is passed down the layers. The addition of a header or trailer is called encapsulation. Now going to differentiate the see-through and the crossover cable. So, Ethernet cables can be wired as straight through or crossover. The straight through is the most common type and is used to connect computers to hubs or switches. They are most likely what you find when you go to your local computer store and buy a patch cable. Crossover cables are more commonly used to connect a computer to a computer and may be a little harder to find since they aren't used nearly as much as straight-through cable. Then, what's the difference between them? Difference between straight-through and crossover cables will be introduced in this blog. So, what is straight-through cable? A straight-through cable is a type of twisted pair cable that is used in local area networks to connect a computer to a network hub such as a router, and this type of cable is also sometimes called a patch cable. And it's an alternative to wireless connections where one or more computers access a router through a wireless signal. On a straight-through cable, the wired pins match. Straight-through cable use one wiring standard. Both ends use T568A wiring standard or both ends use T5688 wiring standard. The following figure shows a straight-through cable of which both ends are wired as the T5688 standard. So next is, what is crossover cable? An Ethernet crossover cable is a type of Ethernet cable used to connect computing devices together directly. Unlike straight-through cable, crossover cables use two different wiring standards. One end uses the T568A wiring standard and the other end uses the T5688 wiring standard. The internal wiring of Ethernet crossover cables reverses the transmit and receive signals. It is most often used to connect two devices of the same type. Example is two computers by a network interface controller or two switches to each other. Choose a straight-through or crossover cable. Usually, straight-through cables are primarily used for connecting unlike devices, and crossover cables are used for connecting unlike devices alike devices. Use straight-through cable for the following cabling. First is to switch to router, switch to PC or server, hub to PC or server. Use crossover cables for the following cabling is to switch to switch, switch to hub to hub, and router to router. Last, router internet port to PC and IC, PC to PC. Thank you. So that will be all. And again, I am Ariel Misalva. Thank you for watching and hope to see you next time. Bye.